Okay. What you can see in the slide, this is a time machine sort of. How to find out the time duration. This is an hourglass. Yes. This is a machine, sundial, and this is Jantar Mantar, which is in Delhi. By casting shadow, you can find out the timing or the time of the day. Okay, so this is hourly glass, you can see. So when all the sand falls down, it takes 1 hour to fall down on one side. It's clear? So this is how they used to find out or measure the time. What is motion? Please read.
Ma'am, may I?
Yeah, sure.
Motion. Motion is some kind of change in the position of the object.
So you agree with this definition, beta?
Yes.
Yes. For example, this is a ball, right? And I kick it or I push it. It goes and it comes here. Agree? So it has left, it was at rest, 0. From A, it has come to B. So the position has changed. What do you say? The position has changed, right? So it is change of position of the object that defines the motion. For example, you are riding a bicycle. You start from a home and you reach somewhere else. So your bicycle and you, both of you are in motion. You are on bicycle, the bicycle is moving, that means even you are moving, isn't it? Hello? Are
Yes,
you
ma'am.
understanding what I'm saying?
Yes, ma'am.
Some more about motion, beta? Start.
Ma'am, can I read?
Sure. Just give me your name and then start reading so that I can
Zainab,
understand who is
Zainab
this.
Rupani.
Okay, beta.
Motion is the change in the position of an object with time. There are different types of motion. They are number one, motion along a straight line. Example,
Rectilinear.
motion of car and
Just a
straight
moment. Beta, you have to read the thing which is written in the bracket as well. Okay?
rectangular
So,
motion.
no, it is just a moment. Let me read and then you follow. Rectilinear. Read it again, beta.
Rectilinear motion.
Very good. See, there
Example,
are two. Just a moment, beta. Don't hurry. It is recti and linear. Just split it into two. So the things will become very easy for you to pronounce. Split it into two. Recti, linear. You understand? So
yes
on
ma'am.
your own, you have to split it on your own. The word should be split on your own. Okay?
Okay
Fine.
ma'am. Rectilinear motion. Example, motion of car and straight road. On
On
a
a
straight
straight road. Read properly, beta. You're leading a class. You have to be very careful. Okay, beta? Everybody's following you. So motion
okay
of
ma'am.
a car on a straight road. This is the example. I will be explaining to you, don't worry. But read properly, please.
Motion
Second one,
of
beta.
car Motion of a car on a straight road. Number
Thank you.
2. Periodic motion. Example, motion of a pendulum.
Very good.
Number
See, you
3.
tried. Thank you, beta. Number
Number
three,
3. Circular motion.
circular.
Example,
Read it
circular
again.
motion.
Yes, good.
Example, motion of the earth around the sun.
So now we are going to do types of motion one by one. First, what is motion? We just did it in the last slide that the change in position of any object with time is called as motion. So, distance upon time, you can say that. What is motion? Distance upon time. Now, we are going to read different types of motions. The first one is a straight line. So, which word comes? Linear. Remember, linear is straight line. So, rectilinear motion we will take as a motion along a straight line. For example, you are riding a bicycle on a road straight. You are moving a car on a road straight. You are using your scooty on the road straight. So all these are rectilinear motion. Any problem? Anything which goes straight is rectilinear motion. Any problem, beta? Hello.
No, ma'am.
Okay. Now comes the periodic motion. That means with time. It is perfect with time. For example, have you got a wall clock at home, beta? At your grandparents' place? Wall clock I'm talking about. So it's got a pendulum. I will be showing you. It's got a, see, this is a clock, and then it's got a pendulum, and it keeps on moving like this. It keeps on moving like this. Tick tock it
Yes,
sounds.
ma'am.
It keeps on chiming. It keeps on making sound. Tick tock like this. So that is pendulum. Okay, and this is called as bob. What it is called, beta? Bob. The thing which is moving is called as bob. That circular thing. The circular object at the bottom of the pendulum is called as bob, and that is periodic because it is controlling seconds, minutes, and hour, right? And then sometime you have to, with the help of key, you have to wind it up. Yes, we with the help of key we wind it up, isn't it? You must have seen all these things happening at home. We don't have. We have got this
Yes,
thing
ma'am.
clock, but we don't have wall clock at home, isn't it? With the pendulum, I'm talking about. We have got wall clock, no doubt about it, but they don't have pendulum. They are all digital. What do you say? So this pendulum used to be there earlier in old homes during our grandparents' time. Nowadays, we don't have this pendulum clock. So it is moving periodically. For example, you swing. You know, if swing, that is called jhula. That is also periodic. So you go back, then you come ahead, then again you go back, and you increase the speed, sometimes you decrease the speed. All these are periodic. Okay? So this you have understood? Now we come to circular motion. For example, Earth is moving around the sun. Rather, we can say the planets are moving around the sun. All the planets are moving around the sun. What do you say? All in circular motion. Moon is moving around the earth. Circular motion. Yes or no? Yes? Girls, can you hear me?
Yes,
Yes?
ma'am.
Yes, ma'am.
Okay. Now you can see here the car is moving on a road. What is this? Rectilinear motion. This is the bob. See, this is the bob. Now it will go here, pendulum, and it will go here. How? It will move first here, then again it will come back, then it will go here, again it will come back. This is called pendulum. This is how it moves. From one, it's like a to and fro motion. It goes ahead, then it comes back, and it keeps on and on throughout. And that's how we get seconds, we get minutes, and we get hours. Right? Now we come to the circular motion. This is sun and this is earth. Or you can say this is earth and this is moon. What do you say? You can take anything, isn't it? Hello? Can we? First, can you hear me? Hello? Girls, can you hear me better?
Yes, ma'am.
Okay. So this much have you understood the types of motion? Do you have any problem? Girls, do you have any problem to understand?
No, ma'am.
Now we come to the second factor, the second, rather not factor, I will say, second topic, that is speed. So motion is over. Now we are coming to speed. Please begin. Yes, girls, please begin.
Ma'am, can I?
Yeah, sure.
Ma'am, but I had read the
Which
first
one?
slide.
First slide. But no one
The
is
first.
giving me, yeah, but better, no one is giving me any response. It's better you continue. Let's not waste our time. Okay?
Speed. Speed. The distance covered by an object is a unit
In,
time is called the
in.
speed of an object.
Okay.
What, ma'am?
It is in a unit time. Okay, read
In a
example.
unit time is called the speed of the object.
Okay.
Example. If a car covers a distance of 100 kilometers in 1 hour and a bus covers a distance of 50 kilometers in 1 hour, then the speed of the car is more than the speed of the bus. Since the speed of most objects are not constant, the speed is the average speed. Speed equals to total distance covered upon time taken. Uniform motion. If the speed is an object is constant, it is in uniform motion. Non-uniform motion. If the speed is of an object keeps changing, it is a non-uniform motion.
Something you understood better by reading little? While reading, did you understand something?
Yes.
Okay. So what is speed?
The distance covered
Distance.
by an object in a span of time.
I've written it down. Speed is distance upon time. Okay, this is speed. Now a car goes for 100 kilometers in 1 hour. Okay, so car is taking 100 kilometers in 1 hour and bus is taking 50 kilometers in 1 hour. Simple. So which one speed is more, car or bus? Which one is taking more distance?
Car,
Car. So whose speed is more?
car,
Obviously. You understood now? Because 1 hour is common. 1 hour and 1 hour is common. So you don't consider that. What you have to consider now? More distance in car and less distance in bus. So obviously the speed of car is more than the bus. Simple. Okay? Now, whenever you are moving by a car, we try to find out average. We don't find speed, but we find average speed. Why? Can you tell me? Because I can take a halt in between. I can stop my car. Maybe I have to change my tires. Maybe I have to go to a filling station to fill my tank. Yes. So these are breakage. These are breaks in the journey. So it is not continuously we are moving, but we are having breaks. So we cannot find the speed, but we have to find out the average speed. Do you understand? Because my car is not in continuous motion. If it is in continuous motion, the speed you can take. But when it is having a break or halt in between, then you have to take average speed. Yes? Girls, are you understanding?
Yes.
Yes? Okay. So speed generally are not constant. I told you why it is not constant. Sometimes it is more, sometimes it is less, sometimes it's zero because it's stopping for a while. So what we take? This will be total distance covered upon total time. That will be a speed. Now we know that most of the objects are not in continuous motion. But we take it for granted that some objects are having uniform motion. What does that mean? That any object, the speed is constant. It does not change from A to B. For example, this is the object and moves to B. The speed remains the same. It is constant. It is called as uniform motion. Generally, it does not happen. Remember that. Generally, we have non-uniform motion because what we find in day-to-day life, the speed of an object, it keeps changing. You agree with me? Do you agree with me or not?
Yes.
So it keeps on changing. So it is non-uniform motion. This much have you understood? Any problem regarding this slide?
No, ma'am.
Now more about speed. Please begin.
Speed. Distance covered by an object in a unit time is called speed of the object. Example. If a car is moving with a speed of 50 km/h,
Per
it
hour.
implies that per hour, it implies that it will cover a distance of 50 km in 1 hour. Speed equals to total distance covered upon total time taken.
Anything new in this slide, beta?
No, ma'am.
No. Fine. Good. Just more of a repetition, right? Now we will revise it. What are the things that we have to remember? Please begin.
Speed. The moment of an object is a unit time is called its speed. Speed is the distance covered divided by the time taken. Speed equals to distance covered upon time taken.
So revision is over. Any problem regarding this, regarding speed? So what is speed? It's the movement of an object in unit time. Yes. So motion upon time is called speed. So motion means distance. So distance upon time is your speed. Am I right? Yes or no? There are two definitions. One is movement, that is called motion, right? That's the first slide that we did. The third slide was distance covered divided by time taken. This is how it is related. See, you can see the formula. So
Yes,
there are
ma'am.
two definitions. There are two definitions. One related to motion and other related to distance covered. Am I right?
Yes.
Yes. So this is what you have to remember about speed. It is distance covered per time taken. Any difficulty?
No, ma'am.
Let's do one numerical. Please begin with it.
Time taken by Selma to reach her school from her house home equals to 15 minutes minus 50
It is not
into 6
minus. It is equal to. Time
equals
taken
to
by Salma.
50.
Should I explain better? That will better. Huh? Let me explain. Okay, better. Hello.
Huh. ma'am.
Let me
Yes.
explain. So, Salma is going to school. Now it takes her 15 minutes. How much time does it take, beta? 15 minutes. You know that whenever we are solving any numerical or any problem, we have to do some conversion. What is that? Minute never remains the same. It has to be converted to seconds. So when we talk about converting to seconds, we know 1 minute is equal to 60 seconds. You agree?
Yes, ma'am.
Therefore, 15 minute will be 15 into 60. Agree? Yes or no?
Yes.
Yes. So if you equate it, if you find it out, 0 remains the same, 5 6 are 30, 5 1 are 5,
900
900.
kilometer.
No, it is seconds, not kilometer. We are converting minute into seconds, beta. Where the kilometer will come down? This seconds. What you will say? Seconds. Have you understood this much? That one conversion,
Seconds.
right? Now,
Yes.
second one. Speed of a bicycle is 2 meter per second. That is given. So 2 meter per second is speed. Time is 900 seconds. So what will be speed? Speed is equal to distance covered upon time taken. This we know the formula as. We know the formula, isn't it? Distance covered upon time taken is the formula. Yes or no? So what is distance covered? So
Yes,
what is
ma'am.
distance covered? We have to find out distance, isn't it? So distance is equal to speed into time. What is speed? 2 meter per second. 2. What is time? 900. Right? Hello? Right or not? What it will be? 2 into 900, 1800 meter.
118.
1800 meter. Again now, this meter we cannot take it as unit because it has to be converted to kilometer. So we know that 1 kilometer is equal to 1000 meter. Agree? Agree or not? Do you know or not? 1 kilometer is equal to 1000 meter. Do you agree? Okay.
Yes.
Or 1000 meter is equal to 1 kilometer. Why we did this? Because I have to convert meter into kilometers. So I have taken it on the left hand side. Therefore, 1 meter is equal to 1 upon 1000 kilometer. Till this, do you agree with me? Do you agree with me, beta? So how
Yes,
many
ma'am.
meters did we find? 1800 meter. What will happen? 1 upon 1000 into 1800. Yes, this 0 cancel. 18 upon 10 becomes 1.8 kilometer. This is the answer. This is the answer you got. So you got the answer? What do you say? What do you say, beta? Are you aware of the conversion formula? How to convert minute into seconds, how to
Yes.
convert seconds into minutes, how to convert kilometer into meter, then meter into kilometer. Do you know all these things or not, beta? Yes or no? I'm just asking you. Do you know or not? Say something, beta. You know. Okay.
Yes.
Whatever I taught you just now is a revision then? Have you understood whatever I taught you just now? Girls, 7th standard. It's for all of you. Did you understand whatever I taught you just now? Why no one is answering? Hello? Girls, do you hear me?
Yes.
Yes, please read with her.
Motion, uniform motion. If the speed of the object moving along a straight line keeps changing its motion, is said to be non-uniform motion.
That's it. Now you see, this line straight, and again it changes. Can you see this? And again it changes. So this is non-uniform motion. What will be uniform motion? If it becomes a straight line. That is uniform motion. But you can see over here, it is changing here, and again it is changing, and again it becomes from here to here it is uniform motion. See, if I talk about this one, from here to here, it is uniform motion. This is uniform motion. But from here and here, it is non-uniform motion. Have you understood? If it is a straight line, it is uniform. If it is uneven or a curved line, it is non-uniform. Agree? Agree or not? Hello?
Yes.
So this is non-uniform motion. You saw? Because the lines are not straight. It's uneven lines. Can you see this? Uneven lines. Now we call it uniform motion. Please start.
Motion, uniform motion. If the speed of the object moving along a straight line with a constant speed, its motion is said to be uniform motion.
See over here. You see the straight line?
Yes.
Yes, the whole thing is straight line. Can you see this? So it is uniform motion. This much have you understood? Have you understood this much? The uniform and non-uniform motion. This has got constant speed. This one has got constant speed, right? And non-uniform has got different speed. Got it? Now again we will revise. What are the points to remember one by one? Please.
Ma'am, can I read?
Okay, beta, what's your name?
Man Sakina.
Okay, Sakina, go ahead.
Points to remember. Non-uniform motion. If the speed of an object move along a straight line keeps changing its motion, is said to be non-uniform.
So what is important over here? Speed changing its motion. That is what you have to remember. Non-uniform motion, speed changing its motion continuously. Okay? Fine. Now we come to uniform motion. Please.
Uniform motion. An object moving along a straight line keeps changing its motion is said to be non-uniform motion. In this case, the average speed is the same as the actual speed.
Over here, you can say the average speed is taken in uniform motion. That becomes the actual speed. Okay? You understand? So in uniform motion, the average speed is taken in uniform motion. I think there's something wrong over here, fan. It does not keep changing its motion. What should be written? Does not keep changing its motion is said to be in uniform motion. So it remains same. There's something wrong in this uniform motion. It does not keep changing its motion. You understand? Whereas in non-uniform, it keeps changing its motion. Any problem? There's some error over here that we have rectified. So what are the points to remember better? It's revision. Yes, continue. Yes, Sakina, continue better. Can you hear me better? Girls, can anyone hear me?
Yes,
Hello? Yes, please continue. What happened to Sakina? She's off the air, it seems.
ma'am, she had left.
Okay, you continue then, better.
Points to remember measurement of time. For measuring time, our
Ancestor,
ancestor
ancestor,
ancestor ancestor used sundial, water
sundials.
clock,
See, beta, if you're
sundials,
stuck somewhere, read it again, please. Don't read it wrongly. Okay, beta? Be careful. You have to read it.
sundials,
Yes,
water
sundials.
clock, and sand clocks.
Fine. So, our ancestor, that means our forefathers, what they were using, you can see over here. This is water clock. This is sand clock. This one is sand clock. You see in the center? This is sand clock. This is water clock. This one is water clock. And these are sundials. Can you see this? These are sundials. Okay? According to a shadow, they will find the time. Now we'll see measurement of time. Please. We have
Good
done the
man.
speed, the motion, uniform motion, non-uniform motion, right? We did the speed. Speed is over. Now we are going to work on time. Start.
We measure the intervals of time. Example, the time interval between one sunrise and the next was called day. A year was fixed as the time taken by the earth to complete one rotation.
So understood now? So what we found? We found, not we, they, our ancestors, day and year. So what is a day? The time between one sunrise and the next sunrise. That is one day. What is year? It is fixed always. Remember, day is fixed, year is fixed. Earth to complete one rotation around the sun. This is sun. Remember, this is sun. So Earth is completing one rotation around the Earth, that is called the year. Now this is fixed. The time interval is fixed. What do you say? A day is fixed and year is fixed. Is it clear?
Yes.
So time is fixed. This is how we find the time. Here you can see the sundial. Can you see this shadow? See this shadow? Can you see the shadow better?
Yes. Yes, ma'am.
So you can find out that this is 4 o'clock or this is 5 o'clock or this is 6 o'clock according to the shadow. So this is sundial. Okay? This is water clock. And this is sand clock.
Sand
Can you
clock.
see this? Yeah, this is sand. So now you know everything. What are sundials, what are water clocks, and what are sand clock. Stand clock is also known as hourly glass. Let's see what are the points to remember.
The watches used today make us the of periodic motion. One of the most well-known periodic motion is that of a simple pendulum.
Okay. Whatever watches we are using these days, they have periodic motion. Okay. The best example is pendulum. Now, in your granny's place or grandfather's, maybe your maternal or paternal, you must have observed the wall clocks. Have you observed these wall clocks? Yes? These are,
Yes.
Yes,
this is called as bob. What it is called, beta? Bob. And the whole unit is called as pendulum. What it is called, beta? Pendulum.
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 Understood now? This much you have understood, beta?
Yes.
Okay. See how it moves.
Yes,
See how it works. Now this will start and it will make a sound. Tick tock, tick tock. Yes, it makes that sound. Hello. The pendulum makes
Yes.
sound. It's a chiming sound. Okay. What will happen? The bob will come here and the bob will go there. Yes or no? This is how it
Yes.
moves. Then again it comes back and it moves here. Again it comes back and this is how it moves. This is periodic motion. What it is better? Which motion is it? Periodic motion. Say.
Periodic motion.
Understood now? So this periodic motion is making a tick tock, that sort of sound it is making, and is controlling seconds, minutes, and hour of the clock. Yes? Yes, better? So this is pendulum. Now this is which? It's a table clock. Can you see this table clock?
Yes.
yes, ma'am.
Can you see a pendulum over here? Can you see a pendulum over here?
No.
Yes,
No, isn't it? Where is it? There's no pendulum. It's a table clock. What about this? This is digital clock. What it is, beta? Digital
Digital
clock.
clock.
There's nothing. No needles. See, it's got needles. Can you see this? These are the needles. These are the needles or arrows. The second needle, the minute needle, and the hour needle. Does this one has anything? No. Is this the number? So this is digital. You can see the difference of the clock. Pendulum clock, table clock, digital clock. You understood?
Yes.
You want me to ask any question, beta? I've
No.
shown you the difference between all the types of clock. Rather, we call this as an alarm clock. Remember, this one is called as alarm clock. Remember? Yes or no?
Yes.
Okay. We see measurement of time. Some more. Please read.
Ma'am, can I?
Yes, sure, beta.
Measurement of time. Time is measured by using clocks or watches. Clocks and watches make use of periodic motion.
Fine. Now, what is the difference between clocks and watches, beta? What is the difference between clocks and watches? There has to be some difference, isn't it?
Yes.
What is the difference?
ma'am. Clock is on wall and watch is in our hand.
Very good, excellent. So watches we wear watches. We don't wear clocks. And clocks are hung on the wall or are put on the table, both. So I've given some extra information that clocks are either hung on the wall or put on the table. Am I right?
Yes.
And we wear watches. It is put on our hand, isn't it? On our wrist, right? Yes, beta? So you can see
Yes.
the types of one by one we'll observe, then you will understand it nicely. That's why I've taken this pic. Wall clocks with the pendulum. Agree?
Yes.
Agree? So it has
Yes.
got a pendulum. Wall clocks have got a pendulum. Okay. Now this is the table clock with alarm. Yes?
Yes.
These are the watches that we wear. Yes? Your papa, your brother, they're wearing these watches. Yes or no?
Yes.
These are clock, but without pendulum. Yes? One on the left hand side. This one. This one. It's without pendulum. Yes or no? But it's a clock which is put on the wall. Yes, beta?
Yes.
Then these are digital clocks. Agree? These are
Yes.
digital clocks. Okay. This is the digital watch. Yes or no? This one. It's a watch which is put on your hand, but it is digital. Yes or no?
Yes. Yes.
So I've shown you all the types of clocks and watches. Now we'll see points to remember. So see, everywhere I'm taking it as a revision part. Do you follow me? What am I doing?
Yes.
Okay. In spite of this, if you are finding any doubt anywhere, please stop me. Read better.
Points to remember. Simple pendulum. A simple pendulum cons-
Consist of,
Ma'am.
yes, I know the
consists
time is up. I know time is up. We'll just take 1 second and finish it up. Yes, better.
a simple pendulum consists of a small metallic ball called bob suspended from a rigid
Digit.
stand by a thread.
We have
When the
already seen
bob
this.
when the bob of the pendulum is released after taking it slightly to one side, it begins to move to and fro. The to and fro motion of a simple pendulum is an example of an oscillatory or a
Periodic.
periodic motion.
What is the motion that the pendulum is doing? Oscillatory or periodic motion. Like this, then it goes here, then it goes here. This is the periodic motion or the oscillatory motion. Have you understood this much? This we have already
Yes.
done. This is the
Ma'am,
revision.
time is up.
I know, beta. I told you, I know. Let me finish one slide at least, beta. Okay, thank you. So I hope you have understood most of the things of today's session. Have a
Yes.
good day, beta. Enjoy and be good to yourself. Bye.
Bye, ma'am. Have a nice day.
Same to you.
Bye, ma'am.
Bye, beta. Sorry for taking some more time.